name is Prasad, Maths IIT lecturer. I have more than 20 years experience. Still I have been in Maths teacher, and just we are going to discuss about functions today class. Functions is one of the biggest part in mathematics. Without function there is no mathematics. And just you see, and today we are going to discuss about one-one functions, especially in these topics. One-one is very, very important. We have a different methods in one-one functions, and we can solve in a graphical method also. That's a very, very important point. Unless we know the graph, we cannot solve the problems, especially in the functions. The major topic is the functions. So that you see, the question f is r tan star is defined by f of x is equal to x plus 3. Then what is f? Whether it is a one-one function or not, we have to check it. Now you see, here the domain is R and codomain is R. And now how to find whether it is a one-one function or not? And just you see this. Here the domain is R. And as per the graph, we can say that according to graphically, the horizontal line intersects the graph of the function at only one point. We can say that it is a one-one function. Suppose just I have a graph like this, and this is x-axis and y-axis, and just I have a graph like this. You draw just a horizontal line. When you are going to check whether it is a one-one or not, if you draw horizontal line, it cuts only one point. But here, if it cuts more than one point, is said to be many one function. So it is not a one-one function. You see here, just it cutting 3 points. So it is not a one-one function. It is said to be many one function. What is the definition of one-one function? Just as per the graph, we can say that just you draw horizontal line. The horizontal line intersects the graph of the function at most one point. We can say that such a function is a one-one function. Suppose if it cuts more than one point, is said to be many one function. So clearly we can say that you see the graph, just you see, and just I drawn the graph, just it cuts more than one point. So it is not a one-one function, which is said to be many one function. What is the definition of many one function? Many one means the two or more elements in set A have the different images, is said to be many one function. So which cuts more than one point is said to be many one. So it is not a one-one function. So how do you become a one-one function? Just you see one more example. Here just you see here an x-axis, y-axis, and just I have a graph like this is a straight line. This is the y is equal to mx plus c. Now you see this here. If you draw one line is parallel to x-axis, it cuts only at a single point. Now which will become a one-one function. Because just when you find out the whether it is a one-one or not, we have to check only domain. So what is the domain of the function here? Is R. For all in minus infinite to plus infinite, this is the graph y is equal to mx plus c. So that we can say that as per the graph, just it cuts, since it cuts only at a single point, then it is a one-one function. Am I right? Now you see this here, it defined what is the given function here, f of x is equal to is a 2x plus 3. So then f is 1-1 or not, we have to check it now. Just because the problems on in this class we have discussed only whether it is a 1-1 function or not, problems on 1-1 functions. So that, and domain is hard, just when you're going to find out whether it is a 1-1 or not, you need to check the domain only. That's a very important point. So here the domain is R. So for this domain, you draw the graph of the given expression. What is the given expression? F of x is equal to x plus 3. Clearly we can say that that is a straight line. I drawn here, just you see, it cuts only at a single point. I took the another example, just you see this, it cuts more than one point. If it cuts more than one point, have a 3 images for one point here, just that means we can say it as per the graph. So it is not a 1-1 function. It is not 1-1 function. Now you see this. This is the function f of x is equal to is 2x plus 3. So clearly we can say that it represents a straight line. This is the form of y is equal to mx plus c. And just you see the function y is equal to is a 2x plus 3. How the graph of this function? Same, just like this we can get it. And this is x-axis and y-axis. Y is equal to mx plus c. It a straight line, which means the coordinate axis. At just like this we can get it now. Now you see, as per the graph, what is the definition of 1-1 function? Just a while ago we have discussed it. Now what is the definition of 1-1 function as per the graph? And just you draw one straight line, horizontal line, which is always parallel to x-axis. So according to graphically, we can say that the horizontal line intersects the graph of the function at most one point. Such a functions we can say that is a 1, 1 functions. Just you draw one horizontal line, it cuts a single point, then it is a clearly we can say that it is a 1, 1 function. That's it. Now let's go for a second problem. Now you see this here also, f is r times to r is defined by f of x equal to x squared, then what is f? And now we have to check it whether it is 1, 1 or not. But here also, what is the domain of the function? Is r. Okay, so here also domain is r. So when we are going to check whether it is a 1, 1 or not, always we have to look at the domain. That's a very, very important point when you find out the 1, 1 functions. We have to check only domain. What is the given expression here? F of x equal to x squared. Now let's go for a graph. Just you see f of x is equal to x squared. But in this problem, I will be presenting two methods. The first method, we have one condition also for 1, 1 function, and just you see, let x1 comma x2 is belongs to R. There is a condition, just I am going to write the condition here beside the problem. F of x1 is equal to f of x2. That implies, and x1 should be is equal to x2, which is said to be 1, 1 function. That is the first method. Let's go for a first method, and this is the function f of x equal to x squared. And for this 1, 1 function, this is the condition. This is the mathematical concept. Just x1, x2 comma belongs to R, because what is the domain of the function? Is R. We have considered just x1 comma x2, two elements belongs to R. F of x1 equal to f of x2, that implies x1 should be equal to x2. We should satisfy the condition. If you get x1 equal to x2, then which is said to be 1, 1 function. Otherwise, it is not a 1, 1 function. Now, as per this, just you see what is the given function f of x equal to x squared. And let x1 comma x2 belongs to given here, just you see f of x1 is equal to x1 squared and f of x2 is equal to x2 squared. So, and what is the condition? F of x1 is equal to f of x2. x1 squared is equal to x2 squared. That implies x1 is equal to plus or minus x2. So what is the given condition here? x1 should get x equal to 2, then it is a 1, 1 function. So here is not 1, 1 function because we got a negative. That means we can say that have a two images, it is not a 1, 1 function. Yes. So we got it extra is a negative sign here. It is not a 1, 1 function. It is a many one function. As per the concept, if it is not 1, 1 function, it is said to be many one. And while ago we have discussed about this concept. 1, 1 means different elements in set you have the different images. What is the many one? Two or more elements in set you have the same image, is said to be many one function. As per the graph, and just it cuts only at a single point, and many one functions, if it cuts more than one point, is said to be many one. Okay, here we got x1 equal to plus or minus x2. Here we got negative sign we got here, so that it is not a 1, 1 function. Now, as second method, by graphically, what is the graph of f of x equal to x square? How the graph of first, let's go for graph just very simply. F of x is equal to given function is x square. And clearly we can say that the x square represents a parabola. Parabola, how the graph of just you see, let us consider, and y is equal to, yes, this is the function y is equal to x square. Suppose here y is always depends on x. When x changes, y is also changes here. Whenever x changes, y changes. This is called a implicit function y is equal to x square. How the graph of it represents a parabola, it represents a curve, and degree of x equal to 2 is said to be represents a curve. If degree of x equal to 1 is said to be represents a straight line. So this is a degree of x is 2, it represents a curve. Suppose when x positive, then y will become also positive. Clearly we can say that for any value of x, x square will become positive for all values of x. How the graph of just I am going to explain, just you see this. When x positive, y positive, and x negative also is y is also positive. Now you see y is always positive in which quadrant? X positive is the first, x positive positive plus plus which quadrant? First quadrant, and x negative y positive which quadrant? Is the second quadrant. So as per this the graph is completely above x-axis because y is a positive, that is a common number, y is a positive. The graph is completely above x-axis. If you are putting x equal to 0, y will become 0. So clearly we can say that the y is equal to x square is always passing through origin and is completely above x-axis and also passing through origin. The graph of the function will be like this. This is x-axis and y-axis. The graph will be and just like this. It represents a parabola. It is always passing through origin. This is one of the method to find out the graph of the function. There is another method is also there, and just and before going to draw the graph of the function, we need to check the whether it is a even function or not. By even function also, how the graph of even functions. Suppose if it is to be even function, the graph of even functions are which are symmetrically about y-axis, and x square plus 1 and cos x, like these functions are always even functions. What is the definition of even function? F of minus x is equal to f of x, then f is said to be is even function. And f of x is equal to, what is the given function? F of x equal to x square, and just we should satisfy the condition. If we replace x by minus x, then we can get minus of x whole square, that is equal to x square. And f of minus x is equal to f of x. Since f of minus x equal to f of x, therefore f is a even function. So how the graph of even functions? As per the graph, we can say that the graph of even functions are which are symmetrically about y-axis. That means we can say that which lies first and second quadrant axis. And just like that, every even function, all even functions are, and just like this only. These are all even functions which are symmetric and besides the first and second quadrant axis, completely which lies on the first and second quadrant axis. That means, so just like this, this is x-axis and y-axis. So therefore, in the f of x equal to, you can solve like this also. The graph is just you see minus x, just whether it is even or not when before going to draw the graph of the functions. Okay, and just you see you can solve like this also. The graph of the function will be like this. Now we have to check it whether it is a 1 1 or not. How do you check it? And a while ago we have discussed. I have given the graph of the functions method. The concept is just you draw a horizontal line. If you draw a horizontal line, the horizontal line cuts the 2 points, and just you see it is not a 1 1 function, which is said to be a many one function. And very simply you can find just like if you know the graph of the function, any problem simply you can find. So I hope you understand. Just you see this is origin. Okay, it is not a 1 1 function. So it's said to be many one function. It's said to be many to one function. Next, go for third question. This is very important. You see, f is minus 1 to infinite. The domain is closed off minus 1 and open off infinity. Tan to r is defined by f of x equal to x square plus 2x plus 4, then f is. Here also, we need to check whether it is a 1 1 or not. It's a different function. This is a little bit tough also. It's very, very important, especially for JEE mains question. Very, very important. So this is also we can do in two methods. And the first method, the normal method, we are going to do this. And before going to solve this question, first of all, we should know the graph of the the function of x square plus 2x plus 4. And how the graph of x square plus 2x plus 4. And just you see, what is the domain of the function is minus 1 to infinite. And minus 1 to infinite domain is closed off minus 1 comma open off infinite. And then what is the given function? F of x is equal to x square plus 2x plus 4. And now we have to draw the graph of the function for this function x square plus 2x plus 4 for the given domain minus 1 comma infinite. The domain is closed off minus 1 open off infinite. How to draw the graph? Clearly we can say that it is a quadratic equation. X square plus 2x plus 4 is a quadratic expression, quadratic expression. And then you see here, make it a perfect square first of all. Now how to make it a perfect square? There is some method here for getting a perfect square. First of all, we need to check the coefficient of x. What is the coefficient of x here is a 2. You can take half of the x coefficient is 2 here, 2 by 2, that is equal to 1. That is the process. We take half of the x coefficient. X coefficient is t, 2 by 2 is a 1. And then we can write, if there is a plus, we can write the x plus 1 whole square. And plus 4 we have to write and the square of this and subtract from this. And then we can write, you see here, f of x equal to x plus 1 whole square and plus 4 minus 1 square is equal to is a 3. And that is, we can write here just x plus 1 whole square plus 3. And clearly we can say that x plus 1 whole square plus 3 is always positive for all values of x. Now you see, because 3 is a positive number, x plus 1 whole square is also positive number. So clearly we can say that x plus 1 whole square plus 3 is always positive for all values of x. And if you are putting x equal to minus 1, and what happened here, this will become 0. The first term will become 0, which is always greater than or equal to 3. That is the minimum value. And before going to draw the graph of the function, we should know that the minimum value of y, it will be minimum only at x equal to minus 1. If you are putting x equal to 1, this will become 0. We can get the value is 3. That is the least value. It will be a least value at x equal to minus 1 is a 3. And now you see this is a, let's go for a graph x-axis and y-axis. Is 0, this is minus 1, this is 1 and 2, etc. and so on like this. And at minus 1, we got a 3. That was the least value. And just this is 3. This is 3, this is the least. And just for this domain, what is the domain of the function? Is closed off minus 1, open off infinite. The graph is completely clearly, we can say that the x square plus 2x plus 4 is also represents a parabola. This is the part of parabola because the domain is minus 2, minus 1 to infinity is given. As per the domain, just you draw the graph of. At this point, we got it already. Is a minimum value is 3. The graph is completely parabola and just like this only. Now we have to check it whether it is a 1, 1 or not. As per the graph, there is a condition for the 1, 1 function. Just you draw a horizontal line. The horizontal line, it also intersect the graph of the function only at one point. So we can say that it is a 1, 1 function. Suppose, same question, when domain changes, then what are going to happen? This is a very important point. You see, when you find out whether it is a 1, 1 or not, compulsory need to check that depends upon the domain of the function. When domain changes, the answer will be changed. This complete domain depends upon domain only. I took the domain here minus 1 to infinite. This is a 1, 1 function. But suppose the domain R, then what is going to happen? Now you see this, the domain is R, just the same, the minimum value is always minus 1. When domain changes also, the minimum value at x equal to minus 1, we got 3. It doesn't change here. Now you see this, the graph of the function will be and just like this only. At this point, this is the point is at x equal to minus 1. When you draw if you draw the graph of the function, it cuts 2 points. It is not 1, 1 function. It is said to be a many 1 function. You see the difference, just you see this. When domain changes, I took the domain is R here, it is not a 1, 1 function. It is a many 1 function. Here if you put x equal to -1, this is the 3. The least value is 3. The graph of the function will be like this. It represents a parabola. It is completely above x-axis. It has been shifted to above 3 units. The graph has been shifted to above 3 units, just like this only. So it is not 1-1 function. It is 1-1 function. Not 1-1. It's many to 1. Next, you go for a second method. This is also very important. And for this domain is -1 to infinity, tans to r is defined by f of x equal to x square plus 2x plus 4, then f is dash. What is the second method? Just you see, we have one concept is there, and just for example, f of x is equal to ax square and plus is a bx plus c. When a is positive, we have some concept is there in the quadratic expressions. When a is positive and b square minus 4ac is less than 0. And the expression ax square plus bx plus c is always positive for all values of x. Yes, we should satisfy these two conditions. So whenever the expression when a is positive and the discriminant b square minus 4ac is called a discriminant. Whenever a positive and b square minus 4ac is less than 0, the expression x square plus bx plus c is always positive for all values of x. As per this also, we can find whether it is 1-1 or not. But you should know before going to solve this question, we have to know this condition. Unless we know this condition, the second method is not possible. And just you see what is the given function, f of x is equal to, but there is a one condition here, where another condition is also there. We need to check the first condition, and second condition is also, it's a monotonic function. Whether the function is a monotonic function means just either strictly increasing function or strictly decreasing function is said to be monotonic function. What is a strictly increasing function? Just like this, the graph of y is equal to is e power x. How the graph of e power x? It's a strictly increasing function, and y is equal to e power minus x also is a decreasing function. The graph of the function will be like this: e power minus x and e power x. You draw one horizontal line. This is also horizontal line. It cuts a 1 point. Clearly, we can say that these two graphs are 1-1 functions. So, what is the condition for 1-1 function? It is a here is f dash of x is greater than 0, strictly increasing function. Here f dash of x is a less than 0 for a strictly decreasing function, which is said to be monotonic function. Monotonic function means either strictly increasing or strictly decreasing function is said to be monotonic function. So every monotonic function is a 1-1 function. This is one of the most important point for checking the 1-1 function or not. Very, very, very important, especially how the problem is very tough. It makes a minimum, and you can use this concept very simply. You can find, and just you see, and one more concept is there for 1-1 functions. The monotonic, just either f dash of x greater than 0 or f dash of x is less than 0. There are two concepts here. And now you see, and f of x, we have differentiated that function, the given function f of x is equal to x square plus is 2x plus 4. We have to differentiate y with respect to x. And then f dash of x is equal to is 2x plus 2, which is clearly we can say that which is always positive for all the domain is closed off -1 to infinite. Is greater or equal to 0. If you are putting x equal to minus, is 2 minus 2 is equal to 0, is greater or equal to 0. For any value of x for this domain, which is always positive. So as per this concept, it's a strictly increasing function for the given domain. So it is a 1-1 function. So we can solve like this also. So for 1-1 function, we have so many methods to find out 1-1 function.